Hi, I'm Wohns.
I'm Reindl.
I'm Olivia Angiuli.
And I'm Rocca.
And this is our CS51 final project on unsupervised learning with handwritten digits. The human brain's ability to recognize handwriting is one of the marvels of our visual and nervous systems. Interpreting handwritten digits is an exceptionally complicated task, but one that has numerous applications. We decided to explore handwriting recognition because it's a great way to delve into machine learning algorithms. We implemented k-means, k-medians, and k-medoids clustering, initialized either randomly or with k-means++.
We implemented k-means clustering as an unsupervised learning method in order to classify handwritten digits from 0 through 9. The k-means algorithm finds clusters of data within a dataset by initializing k cluster centers, assigning each data point to the cluster whose center is closest to it, recalculating new cluster centers, and then repeating the cluster assignments and center recalculations until none of the cluster assignments change. Here, distance is calculated in terms of the sum of squared differences between pixel intensities. We also implemented k-medians and k-medoids clustering, which are extensions of this algorithm. In addition, we attempted using k-means++ as a way to improve the initialization of cluster centers such that they are well distributed among the data points. We were then able to classify new images from a test set that the algorithm had never seen before by finding the cluster center whose distance from that image is minimized, and then categorizing that digit as the majority element of the corresponding cluster.
Here's our code running the k-means algorithm on 5% of the data with k++ initialized clusters. As it runs, it will output its clusters. We also built a Django framework for a front-end environment to recognize the digits. Here you can see me input a 3, and the code will predict a 3, which shows that we have an accurate code base. We also have an interactive IPython notebook that allows you to see what our code outputs in a top-level view. You can see all the graphs, all of the data, and how we classify image inputs through the top level.
There's a positive correlation between accuracy and algorithm runtime. Faced with this trade-off, we use the elbow method to estimate an optimal cluster number for each of our algorithms. Comparing runtimes of these improved algorithms ultimately yielded optimal results for randomly initialized k-means clustering.